According to the National Electrical Code, specifically Section 680.40, a listed cord and plug-connected spa or hot tub must be located not less than 5 feet from the inside walls of any building or structure, and from any other objects except another spa or hot tub. This 5-foot rule is important for safety reasons. It helps to prevent electrical hazards around water, which is a very serious concern. This requirement applies to all parts of the spa or hot tub, including electrical outlets and boxes. The fact that an electrical box is blanked off, meaning it is no longer in use, does not exempt it from this 5-foot clearance requirement. If an electrical box is located within 5 feet of the hot tub, even if it is not currently being used, it is still considered a violation of the National Electrical Code. To correct this violation, there are 2 main options. Firstly, the blanked-off box can be completely removed. This involves disconnecting the wiring from the box and removing the box itself. Secondly, the box can be relocated to a location that is at least 5 feet from the hot tub. This would involve extending the wiring to the new location and installing the box there. It is important to note that any electrical work should be performed by a qualified electrician to ensure that it is done safely and in accordance with all applicable codes. This is especially important when working with electricity near water. The 5-foot clearance rule is in place to protect people from electrical shock and other hazards. It is important to follow this rule carefully to ensure the safety of everyone around the hot tub. When dealing with electrical installations near water, there are several crucial safety considerations to keep in mind. Firstly, ground fault circuit interrupters, also known as GFCIs, are essential. GFCIs are designed to detect ground faults, which are electrical leaks that can occur when electricity strays from its intended path. If a ground fault is detected, the GFCI will quickly shut off the power to prevent electrical shock. All electrical outlets in the circuits near water should be protected by GFCIs. Secondly, proper grounding is vital. Grounding provides a safe path for electricity to flow in the event of a fault. All electrical equipment and systems should be properly grounded according to the National Electrical Code. Thirdly, waterproof or weather-resistant enclosures should be used for all electrical components that are exposed to water or moisture. These enclosures help to protect the electrical components from the elements and prevent corrosion and electrical shock. Fourthly, it is important to maintain a safe distance between electrical equipment and water sources. The National Electrical Code specifies minimum distances that must be maintained between electrical equipment and water, such as pools, spas, and hot tubs. Fifthly, regular inspections and maintenance are necessary. Electrical systems should be inspected regularly by a qualified electrician to identify any potential problems. Any necessary repairs or maintenance should be performed promptly to ensure the continued safe operation of the electrical system. Sixthly, it is crucial to use the correct wiring and components. All wiring and electrical components should be rated for the intended use and environment. Using the wrong wiring or components can lead to overheating, electrical shock, or fire. Seventhly, it is essential to follow all applicable codes and regulations. Electrical work must be performed in accordance with the National Electrical Code and any local codes or regulations. This helps to ensure that the electrical system is installed and maintained safely. By following these safety considerations, you can help to prevent electrical hazards and ensure the safety of everyone around water. It is always best to consult with a qualified electrician if you have any questions or concerns about electrical safety. Remember, electricity and water can be a dangerous combination, so it is important to take all necessary precautions. National Electrical Code Section 680 covers electrical installations for swimming pools, spas, hot tubs, and other similar installations. This section provides specific requirements for wiring methods, grounding, bonding, and equipment placement to ensure safety and prevent electrical hazards. Understanding the requirements of NEC 680 is essential for anyone involved in the installation or maintenance of electrical systems near water. Here are some key aspects of NEC 680. Firstly, wiring methods. NEC 680 specifies the types of wiring methods that are permitted for use in and around swimming pools, spas, and hot tubs. These wiring methods must be suitable for wet locations and resistant to corrosion. Common wiring methods include rigid metal conduit, intermediate metal conduit, and liquid-tight flexible metal conduit. Secondly, grounding and bonding. Grounding and bonding are critical for preventing electrical shock in and around swimming pools, spas, and hot tubs. All metal parts of the electrical system, including the pool structure, metal conduit, and electrical equipment, must be properly grounded and bonded together to create a low impedance path for fault current. Thirdly, equipotential bonding. Equipotential bonding is a technique used to minimize voltage differences between different metal parts in and around a swimming pool, spa, or hot tub. This helps to reduce the risk of electrical shock by ensuring that all metal parts are at approximately the same voltage potential. Fourthly, GFCI protection. Ground fault circuit interrupter protection is required for most electrical circuits serving swimming pools, spas, and hot tubs. GFCIs are designed to detect ground faults and quickly shut off the power to prevent electrical shock. All outlets within a certain distance of the water's edge must be GFCI protected. Fifthly, underwater lighting. Underwater lighting fixtures must be specifically designed and listed for use in swimming pools, spas, and hot tubs. These fixtures must be installed in accordance with the manufacturer's instructions and must be properly grounded and bonded. Sixthly, electrical equipment location. The National Electrical Code specifies minimum distances that must be maintained between electrical equipment, such as outlets, switches, and junction boxes, and the water's edge of a swimming pool, spa, or hot tub. These distances are intended to prevent electrical hazards and ensure that electrical equipment is not accidentally submerged in water. Seventhly, spas and hot tubs. In addition to the general requirements for swimming pools, NEC 680 also includes specific requirements for spas and hot tubs. These requirements address issues such as heater protection, control location, and bonding of metal parts. The 5-foot rule mentioned in NEC 680.40 is just one example of the many safety requirements contained in this section. It is important to carefully review and understand all of the applicable requirements before performing any electrical work near a swimming pool, spa, or hot tub. Ignoring these requirements can lead to serious electrical hazards. In addition to the specific requirements of NEC 680, there are also some general electrical safety practices that should always be followed. Firstly, always turn off the power before working on any electrical equipment. This will help to prevent electrical shock. Secondly, use insulated tools when working with electricity. Insulated tools will help to protect you from electrical shock. Thirdly, never work on electrical equipment when you are wet or standing in water. Water is a good conductor of electricity, so this can increase the risk of electrical shock. Fourthly, inspect electrical cords and equipment regularly for damage. Damaged cords or equipment can be a safety hazard. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, so it is best to leave it to the professionals if you are not sure what you are doing. By following these general electrical safety practices, you can help to prevent electrical accidents and injuries. Remember, electricity is a powerful force, so it should always be treated with respect. When working with electrical systems, it is also important to understand the different types of electrical circuits. The most common types of electrical circuits are branch circuits, feeder circuits, and service circuits. Firstly, branch circuits. Branch circuits are the circuits that supply power to individual outlets, lights, and appliances. These circuits are typically protected by 15 amp or 20 amp circuit breakers. Secondly, feeder circuits. Feeder circuits are the circuits that supply power from the service panel to sub-panels or other distribution points. These circuits are typically larger than branch circuits and are protected by larger circuit breakers. Thirdly, service circuits. Service circuits are the circuits that supply power from the utility company to the building. These circuits are the largest circuits in the electrical system and are protected by the main circuit breaker. Understanding the different types of electrical circuits is important for troubleshooting electrical problems and ensuring that the electrical system is properly sized and protected. It is also important to understand the different types of electrical conductors. Electrical conductors are the wires that carry electricity from one point to another. The most common types of electrical conductors are copper and aluminum. Firstly, copper conductors. Copper conductors are the most common type of electrical conductor. Copper is a good conductor of electricity and is relatively resistant to corrosion. Secondly, aluminum conductors. Aluminum conductors are less expensive than copper conductors, but they are also less conductive. Aluminum conductors are also more susceptible to corrosion than copper conductors. When selecting electrical conductors, it is important to consider the ampacity of the conductor. Ampacity is the maximum amount of current that a conductor can safely carry. The ampacity of a conductor is determined by its size, material, and insulation type. It is also important to consider the voltage drop in the conductor. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause appliances to malfunction or not work at all. In addition to the National Electrical Code, there are also local electrical codes that must be followed. Local electrical codes may be more stringent than the National Electrical Code. It is important to check with your local building department to determine the applicable electrical codes in your area. When performing electrical work, it is important to use the proper tools and equipment. This includes items such as wire strippers, pliers, screwdrivers, and voltmeters. It is also important to wear appropriate personal protective equipment, such as safety glasses and gloves. Electrical work can be dangerous, so it is important to take all necessary precautions. If you are not comfortable performing electrical work yourself, hire a qualified electrician. A qualified electrician will have the knowledge and experience to perform electrical work safely and in accordance with all applicable codes. They will also be able to troubleshoot electrical problems and make necessary repairs. When hiring an electrician, it is important to check their credentials and ensure that they are licensed and insured. You should also ask for references and check their online reviews. A good electrician will be able to provide you with a written estimate of the cost of the work before they begin. They should also be able to explain the work that they are going to perform and answer any questions that you may have. In conclusion, electrical safety is of utmost importance, especially when dealing with installations near water sources like hot tubs and spas. Adhering to the National Electrical Code, particularly Section 680, is crucial for preventing electrical hazards and ensuring the safety of individuals using these facilities. The 5-foot clearance rule outlined in NEC 680.40 is just one example of the many safety measures that must be followed. It is essential to understand and comply with all applicable codes and regulations, use appropriate tools and equipment, and take necessary precautions when performing electrical work. If you are unsure about any aspect of electrical safety, it is always best to consult with a qualified electrician. Remember, electricity and water can be a dangerous combination, so it is important to prioritize safety and follow all recommended guidelines to prevent accidents and injuries.